Okay, everyone hear me okay? Let's get the slides up. Okay, as our host has said, this talk will be the life and death of dev environments. It sounds a bit dramatic, but don't worry, you'll all be okay. We'll start the talk by a simple introduction. So I'm Toma Puljak, software developer and advocate at Daytona. I'm the guy that argues with our CEO every day. That's very true. And I'm part of the core team at Daytona. 2 lines about Daytona itself. So Daytona is an open source development environment manager whose main focus is to simplify your life, to make you as productive as possible by handling everything from your development environment setup. And most of the stuff I'll talk about here today are lessons learned from Daytona. So to start off the talk, we'll talk about what even is a development environment. Most of you here probably know what a development environment is, but we'll still go over it. Then we'll see what a busy life that development environment sometimes leads. But then we'll standardize to offload. We'll kind of offload that busy life. And then finally, we'll kill it. We'll write out the peaceful death of our development environments. And of course, as with all the talks in this conference, the answer to everything will be AI. But not in the sense you probably think. Well, we won't kill our environments by just injecting some software AI, some AI engineer that will take over everything. But in due time, you'll see that there are stuff to be done here. Before we start, I want to talk about a concept that's gaining more traction now in the development, let's say, lingo, and that's the inner and outer loop. So the inner loop of your development lifecycle actually contains everything you do while developing. It's your IDE, your debugger support, your OS utilities, your source code, and everything else. That's basically all the tools you actually use, I don't know, GitHub Copilot and whatever. While the outer loop is actually something that takes over once you actually commit your code, push it over to some pipeline or CI/CD process. The outer loop contains nothing more, nothing less than what you need to package your application and prepare it for production. As you'll see, this concept will be important for some standards that I'll talk about real soon. Okay, so what even is a development environment? So to start, your development environment has to have access to your code, of course. That code has some project libraries you need while working, I don't know, React, Next.js, or any package you need. Then you have some system-wide packages, for example, Git, curl, wget, vim for some reason or whatever. And then you have your IDEs. So IDEs, actually, you need to take care of them. You need to install extensions, configure settings, blah, blah, blah. The IDE itself is a big part of your development environment. And lastly, you need some compute resources. So these days, you need a GPU probably. If you're working on AI, you need some CPU, RAM, storage, whatever. And all these components are parts of your development environment, and all these components need to be taken care of, and we hate taking care of this. We hate installing some system-wide packages. We hate installing project libraries, configuring IDEs, and everything else. And that's where the busy life of our development environments actually comes into play. So imagine a fresh environment. You bought your new laptop, nothing installed on it. And then you have to work on a Golang project. For example, you need Golang version 1.22 and you need Postgres v16. Okay, you just install it locally and you can develop the Golang project. That's fine. Then you move on. You actually want to be an AI engineer, so you need to install Python now. And now you install Python version 3.12. That's fine. Your brand new MacBook can handle all of that. No worries. A third project comes along because you're working at some company that has some legacy JavaScript projects that work on Node version 16 and MySQL version 5. You install that as well. And now your development environment has all these binaries, all these runtimes, and that's totally fine. You're still golden up until this point. Then you actually do something, let's say, more recent, and you need to upgrade to Node version 20 and MySQL version 8. So what do? You just bump up the dependencies. You bump Node to version 20, MySQL to version 8. You're fine. But what happens when you have to go back? What happens when you have to go back to version 16 and version 5? Well, you can do one thing, which is maintain both the binaries, make your development environment even busier. Or you can switch between the binaries as you work on different projects, different branches, for example. And that's a huge hassle. It's a huge pain in the ass, and no one actually wants to do this. So we want to standardize to offload our development environments. And by standardize, I mean use a concept called standardized development environments. And these standardized development environments will standardize part of our development environment, and part of it is already standardized, quote unquote. So I'll imagine that your code and project libraries are already standardized because they're hosted on Git, SVN, whatever. In my last talk, I said if you don't use Git, you can just leave right now because this all doesn't make sense then. Your code actually is on GitHub, GitLab, Bitbucket, whatever, and the project libraries are probably handled as well. If you use Rust, you have Cargo. If you use Node, you have NPM and Yarn. That all works out of the box, and that's nothing novel there. The hard part is actually standardizing system-wide packages, your IDE, and compute resources. So installing the right version of curl, the right version of Git for your architecture, for your OS, that's something that everyone hates doing. And that's something that companies tend to actually tackle by giving you a machine that's already pre-configured with all the libraries, with everything you need working, but someone has to do that. That's, again, time lost and productivity lost. Then your IDE, you have to install this Python extension, that Go extension. You have to configure these settings. You have to configure, I don't know, tab width in VS Code, whatever. Everyone hates to do that. And finally, you need compute resources. You have to have enough RAM, GPU, CPUs, whatever. Especially if you're working on remote environments, you have to provision a VM that's remote that has enough resources to cover the entire project. And that, again, someone needs to provision, someone needs to take care of it. And that's where we will introduce a concept called development environments as code. We will actually standardize all of this with code, and that's why it's called development environments as code. And the benefit of this is that the actual configuration will be part of your code base, so everyone that has access to the project will actually have a standardized environment and be ready to go from day zero. So let's take a look at a couple of standards. So the first standard is the most obvious one, and that's Docker. Everyone uses Docker. I mean, not everyone, but most developers actually use Docker according to Stack Overflow. And Docker actually started off as a tool to actually package the applications for deployment, but it's actually used for development more and more these days. So for example, you can write out a Docker file with Node and Git, Vim, I don't know, sudo or whatever. And this Docker file is then committed to your repo. Everyone who works on that project can just start up a container from this Docker file and work inside the actual container and have all the dependencies. But while Docker is great for standardizing, I don't know, system-wide packages, what about IDEs and compute resources? How can you actually use Docker to say, okay, when I connect to the container, how can I install these extensions, these settings, so on? And how can you actually say to Docker, okay, I need a VM with, I don't know, GPU, I need 2 gigs of RAM or whatever. That's where a couple of other standards based on containers can help us out. So the first one is dev containers. And dev containers are a Microsoft created standard. They're open source and they're very accessible. You can actually go to this URL and learn everything about dev containers. They also have a CLI tool available on GitHub. Dev containers have a very easy to follow, developer friendly, as I like to call it, a JSON schema. So as you can see here, this is the minimal example to actually define a Rust dev container. You can see we have a name for it. We have a Docker compose file, the service name, workspace folder, and probably the most interesting part here is the post create command. So dev containers have these lifecycle commands, for example, post create, post start, on create, and whatever. And these commands will execute inside a container once you start or create it. This means that every developer working on this project, once they boot up the dev container, will have all the packages installed. They don't have to run a single thing. And moreover, all of this can be cached as well. Something that dev containers solve, as I said, are customizations or IDE customizations. So for example, here you can define which customizations need to be applied when you open up the dev container in VS Code. The same thing can be applied to JetBrains IDEs, to any other tool that supports dev containers. So for example, here I say, okay, I need these settings applied to VS Code once I access the container, and I need the Git Lens extension as well. Now you don't need to share these extensions over Slack or message each other, okay, what's that cool extension? You can just commit that to the project, and everyone in the company can actually share the same configuration. And lastly, with dev containers, you have host requirements to handle the compute resource side of things. So here you can define, okay, I need 2 CPUs, I need 4 gigs of RAM, 32 gigs of storage, and a GPU. So with these host requirements, once a dev container is booted, if it notices you don't have enough resources to provision, it will either warn you or completely ditch you from creating that resource. And these requirements apply to your local machine and any other remote machine that might actually spin up these dev containers. And dev containers have great IDE integrations already. So you have a native VS Code extension you can install, just run reopen in container, it will scan through the configuration and open up the container in a couple of seconds. And the exact same command is actually available in all JetBrains IDEs. So dev containers are open source, container-based, they have great IDE integration, very easy to learn, a lot of resources out there. But now something else, something also container-based, but managed by the Cloud Native Computing Foundation, which manages a lot of open source projects like Kubernetes, for example. And so the dev file is very, let's say, Kubernetes oriented. It's YAML based, and the funny thing, not a funny thing, but a great thing for dev file is that you can actually write Kubernetes manifests directly in the configuration file and have all the customizations of Kubernetes, but translated to development as well. As you can see here, this is a minimal dev file example to define a Golang container to develop a Golang project. And dev files actually declare themselves as a kube native API for cloud remote workspaces. This means it's actually very, let's say, compatible with teams that run Kubernetes, but you can also use dev files without ever touching Kubernetes in your life. And dev files have a great ecosystem story, so you can easily manage and publish dev files remotely. You can create your own registries of dev files inside your company, inside your team, or use the publicly accessible ones, and then just reuse them, extend them, and let's say create these hybrid dev files for any other configuration inside your company and your team. But there's one special tool with dev files that's probably the most useful tool regarding dev files, and that's called Odo. It's the, let's say, de facto dev file CLI tool. And the great thing with Odo is that it actually leans into the inner and outer loop story that I mentioned at the start. So the inner loop part is actually running Odo dev. So when you run Odo dev, it will actually boot up the dev file in its development mode, let's say. It will have all your debuggers, LSPs, IDs, extensions, and whatever. But when you run Odo deploy, it will actually deploy the entire application using the exact same configuration, but just packaged for your cluster without all the fuss of the, let's say, inner loop stuff that you have. So you can use the exact same tool in development and for production as well. So for example, you can install Odo in your CI/CD and just run Odo deploy, and you should be good to go. And as with dev containers, Odo and dev files are supported in VS Code as well. There's an IDE extension that can actually even help you out with creating dev files or actually managing them remotely on AWS Code Catalyst and OpenShift. So dev file and Odo, again, open source, kube native, they have a great ecosystem around them, and they're inner and outer loop by design, actually. And lastly, the last standard I want to cover today is a standard that's not even based on containers, and that's a whole different paradigm from the two I shared before, and that's Nix. And Nix is a purely functional package manager. So what does this mean? This means that Nix treats packages as values in a functional programming language. So a Nix package is completely immutable and completely, let's say, independent from all the other packages on your system. So this is actually a directory of some Nix package. And as you can see, the first part of the actual package name is a hash. And that hash is actually a hash of all the dependencies of this Firefox package. And this means that even if a single dependency of Firefox changes, you will get a completely different Firefox package. This means that when you install Firefox on your machine or any other Nix package, you are completely sure that nothing can break because all the dependencies are actually part of the package itself. One more powerful thing about Nix is its Nix shell CLI tool. So for example, you can here you can run Nix shell and add git, neo, vim, and node.js, and really quickly actually enter a shell with these 3 packages installed. This is a very powerful tool for actually testing your application in different environments. For example, different node runtimes, different, let's say, database runtimes, and any other different scenario you might need. You can just execute a command, enter a shell, and test out your code in these different environments. But since we are talking about development environments as code, Nix also supports defining all the packages as code as, let's say, Nix files. So for example, here you can define some packages for, again, Node.js, TypeScript, LSP, Yarn, and Git. And once you run the Nix CLI, it will install all of these packages on your system. And as I said, because the packages are completely independent, you're sure that all the packages work independently and, let's say, combined on your system. But something else that Nix has that all the other standards don't, and that's called Nix OS. And Nix OS is actually a fully fledged operating system that's based on Nix and Nix files, that's completely secure and reproducible and standardized. So for example, here you can see that you have to define the bootloader, the file system, SSHD, I don't know, any other OS setting that you need to define through a set of Nix configuration files. And now, just a small break. Oh. Hydration, very important. Okay. So, as I said, NixOS, completely reproducible, completely standardized, but not only that, it's completely immutable and secure. Why is it so secure? So when you define something as a Nix value, as something in this Nix configuration file, it can never be changed without actually rebuilding the entire OS. What does that mean? That means nothing, let's say, malicious can actually be injected into your OS without first rebuilding the entire operating system and actually modifying the configuration files. And also, it has great support for atomic upgrades. What does this mean? This means that you can actually run a Nix OS upgrade of your OS and actually plug out your laptop. You don't have to worry about your battery dying. There's no blue screen of death. If something fails during the build process, it automatically reverts to the last, let's say, stable state, and you're good to go. You just fix what needs to be fixed, run the build again, and that's it. This is also very powerful for you that run some legacy projects from, I don't know, 10 years ago. If you have a NixOS build from 10 years ago, you can switch to the build itself in a few lines of code, and you're actually checked out to the, I don't know, most legacy state of NixOS that you want. So it's actually very, very powerful for companies that have these, let's say, long-lasting legacy projects as well. So that's NixOS, fully open source, as all packages. I can see I love open source. It's a functional package manager, but also a fully secure OS that has atomic upgrades. It's fully secure, fully immutable from the ground up. Okay, so that's, let's say, development environments as code. So you have these standards. What do? You choose one. You learn the standard itself, you apply it to your project, iterate on it a little bit, and you should be good to go, right? But there's actually some maintenance involved. Someone in your team actually has to study the standard, has to figure out what needs to be included in the standard, what doesn't have to be included in the standard. Does it work for the project? Should you use, I don't know, Odo or dev files or Nix or whatever? And of course, AI can help us here. So the answer is not actually let's raise our feet up and let AI do everything. But let's actually write out the peaceful death of our development environments. So first, a quick course on how LLMs work. The course is actually 2 slides. You have an input, you take that input, a question, I don't know, a prompt, whatever. You give it to an LLM, or as everyone likes to call them, AI now. that AI or LLM has some context that you give it, and then it produces an output. That's it. That's the most basic example of how an LLM works. So let's go through these steps and define what we need to define. So an input, in this case, is really easy. It's generate a dev container config, generate a dev file, generate an NixOS config, I don't know, Docker file, Docker compose file, generate something. But what's the context? So when thinking about context for LLMs, I always like to ask myself, okay, if I have this input, if I want to generate a dev container config, what do I need to know about the project to actually write the config file myself? So for example, I need to know, does the project have a database? Which database runtime does it use? Does it have a separate API and front end? Does it run Node? Does it run Rust? Whatever. What's written in the README actually? Do I have to install this version of Git, this version of curl, whatever? And the important thing here is that 99.9% of the time, you don't have to know the entire project. You don't have to know every single line of code. You have to know these basic, let's say, structural facts about your project, and that's your context for the LLM. And what's the output? Again, pretty easy. It's a Docker compose file. It's a dev container config. It's a set of NixOS configuration files. It's your SDE configuration, your development environment as code that you can just take and then commit to a repo, and that's it. You have a fully working SDE, you and your entire team. And we actually built out a tool. It's at devcontainer.ai. So using the tool, you can actually paste a GitHub repository inside a GitHub repository URL. We will scan through the repo and actually offer you, let's say, hopefully working dev container configuration file. And you can use it now. It's actually live and completely free. But there's another but. There's, again, maintenance to be covered here. So someone has to always keep in mind, okay, when someone changes something in the project, do I have to go back and change the NixOS configuration? Do I have to change the dev container configuration? Did someone update, I don't know, the version of Go in the Go mod file? Do I have to bump it again in the container and whatever? And again, AI. Did I die? Okay, I didn't. AI will come to the rescue here. So imagine this scenario. This will be, let's say, a higher level overview. Disclaimer, we haven't built this yet. But imagine an agent that is actually deployed in your GitHub repository. For example, an application, GitHub application in GitLab and whatever. It scans PR, so when a PR comes in, it can scan the PR, scan the diffs, and then suggests actually edits on your SDE configuration files based on the changes. For example, as I said, if someone modifies the Go mod file in your project and it detects, I don't know, the bumping of the actual configuration, the language version, it can suggest, okay, I see you're using dev containers, you need to bump up Go here and whatever. And then you actually have a config that is completely in sync with your project. You don't have to worry about, not only you, but no one in the project has to worry about, okay, did we sync up the configuration file? It's actually always in sync. That means there's actually now zero worries, zero maintenance, and you can actually just focus on coding, or as we like to say it, you have maximum developer velocity. And this all sounds actually really cool. It's something that everyone should use. But if there's one actually thought from this talk I want you to take, it's just choose any standard. It doesn't have to be any of these standards that I mentioned. It can be any other standard out there. There's actually a lot more of them available. When you choose it, use AI to your full advantage and just forget about it. Just use it, enjoy the max dev velocity, enjoy not having to worry about any of this, and just focus on your work and focus on coding in the end. That's it. You can actually use Daytona right now to create dev container projects out of the box. We natively support it with NixOS, NixOS, and dev file support coming later this year, hopefully. And that's it. If you have any questions, feel free to ask. Thanks for being here.